Welcome to how Salesforce runs Slack apps at scale with Heroku. I appreciate you guys coming to the session. Now, quick forward-looking statement. What I always want to say here is don't make any purchase decisions on products that are not currently for sale. Full stop. That's it. All right, so why are we here? What are we talking about? Now, we're here, I feel like, because of two things come together. When we're talking about Heroku, which is platform as a service, code, we're talking about Slack, productivity, we're talking about productivity at scale. Slack, massively used tool. Heroku, something that's on the back end where you can create applications to run at scale at companies that then allow people to get more value out of that productivity tool. So, to start us off before we kind of get into this and kind of get into what's what, just a quick show of hands. Who uses Slack on a daily basis? See, a lot of hands, a lot of hands. I want to get you using Slack. I'm going to get you using Slack too. You're going to use Slack by the end of the day. And then anyone worked with Heroku before? All right, good. We've got some people working with Heroku that helps us kind of right size in the conversation. Speak to some of you out there. Excellent. All right, so here's the agenda for today. Custom apps operating Heroku at scale. This is at Salesforce. It's across 80,000 employees that we're using these apps with Heroku running the stuff at scale in the back end. We're going to get some architecture and design principles. We're going to run a demo, and then we're going to have some Q&A. So let's get into it. All right, me, myself, Yadin de León. I'm at Heroku. I'm in charge of customer advocacy, getting in there, talking to customers, being there where the people are, community, love the community. This is my partner in crime, Tran, principal software engineer, who's going to be running you through a lot of the architecture and the demos today too. So this is the guy for the technical questions. Grab this guy at the end too, especially if you want to dig in deep. All right, custom apps currently running, operating with Heroku at scale, at Salesforce, integrated with Slack. Of course, like I said, 80,000 employees accessing this communication platform and the productivity tool, scaling multiple apps, leveraging the Heroku platform as a service for those who haven't been familiar with Heroku before. Heroku is a we speak your language platform as a service. If you're building apps and you want to build them with Python, with Ruby, with Go, with various different programming languages, and you want to be able to plug into and connect to the data that's in your Salesforce ecosystem, you want to be able to have hooks into Slack, power your applications at scale, Heroku is the platform that you can leverage in order to be able to do all those things. Saving time, saving money, driving corporate goals and initiatives, those are the things that these apps are able to do. The power of Heroku behind Slack in collaboration allow you to be able to achieve those things. So we're going to go through some of the ones that are actually running right now. Task Hub. One of the great things too, when you're onboarding at Salesforce, you have all of these tasks, all these things that you have to do. They can all float into one place. You've got this procurement thing. You've got this training you need to accomplish across 80,000 employees, all aggregating on one scalable platform in the place where everything gets done on Slack, where I love to do things. All that can get done in one place. And here's an example of $2 million as in licenses returned. Now, those licenses were for other products, other tools used to do those things. Creating an application running across 80,000 employees within the Slack ecosystem allows us to take those back and then leverage this application in-house, run that at scale for all the employees to use. Approvals, oh my goodness. 3,310 years saved. I love this one. That's a lot of time. Turning a 2-day process into a 2-hour process. Heroku running in the back end to make that app scale across all the employees. Ask Concierge, IT issues, you want to be able to make inquiries. 68,000 issues resolved without human interaction. Now, we're not trying to get rid of any of the humans, but there's a whole lot of work that we know gets backlogged that the humans would like to do that gets through automated processes now can be done more efficiently, and people can get what they want and get on with their day. Finally, this is a great example, Einstein. Some of you may be familiar with Einstein. That is our AI app to be able to do lots of different things. Summarize documents, ask questions based on knowledge base. That's accessible through Slack across all the employees with Heroku running in the back end. At the very first start, you can see 12,000 users already in the first month, 120,000 queries, 2,000 meetings scheduled, all sorts of things you can do with this large learning model through Slack at scale with Heroku on the back end. Now, I wanted to start out with these examples so you get context. Multiple apps running through Slack, across 80,000 employees. Now we're going to go ahead and get into sort of the nitty-gritty. But before we get into architecture and demo, who is already building large apps with Heroku at scale? Anybody building across 5K plus? Okay, we've got one person in there, 2 people there. Anyone else? We're going to get you building apps at scale with Heroku on Slack, okay? By the end of the day, we'll do a mini hack. Actually, we're not going to do a mini hack. We're just going to do a talk. But you can meet with us later. We're in the campground area if you want to talk to us more. Slack and Heroku, both there. All right. Anyone building apps with Slack, just in general? Just building stuff, hooks into Salesforce data, hooks into Slack. Okay, I know it's probably some of the same hands raising. All right, so we're going to make sure that we're addressing some of those things. And feel free during the Q&A or right after the session to come up and talk to us if you got any more questions. All right, architecture and design principles. I'm going to hand it over to Fee. He's going to walk you through it.
Thanks, Yadin. All right, let's talk about some architecture and design principles. And before that, let's level set and define what is scale, specifically what is scale to us. So as a team, we wanted to come together and just figure out what are the top things we think about scale. And so the first one, like most of you when you think about scale, is your application stack to be able to tolerate increased traffic and load. This is both horizontal and vertical, and Heroku makes it really nice for us to do that by allowing us to increase the size of dyno we use. So that increases CPU and memory capacity, as well as the number of instances of your application you can run at one time. Also, when we think about scale, we think about supporting growth within the company, right? Our applications are only internal, and as we hire more people, as we integrate more systems, we don't have to change very much about our system, and it just works. And then the third one, when we think about scale for us, is the ability for our application to be supported by multiple teams across the globe. We have team members in different time zones, things like that. Okay. All right. I want to talk about the problem that we were trying to solve. So as employees, we get inundated by a lot of things every day to do. It's like enrollment season and you got to go sign up for your benefits, or you need to log feedback for your peers. What if you own like an application and you need to approve access for people? And in the age of Slack, all these went to email previously. And we noticed that it took a lot of time for people to complete these tasks. And so our job was to bring all these alerts, all these notifications into Slack where people worked the most, the main application, the main focus. And so we need to figure out an architecture that we wanted to solve this problem. And we landed on event-driven architecture. Okay. And I'm going to provide a few stats for you folks and before we get into the nitty-gritty. But right now we are integrated with 15 external systems. That's both Salesforce instances and third-party systems like our HR system or expense system. Again, 80,000 employees at Salesforce using this application or using our systems or applications, and that's growing. And then finally, we're about processing about 30 messages a second and 150 messages a second. And if you ever worked with event-driven architecture, this is nothing, right? Like I've seen systems in our industry process tens of hundreds of millions of messages per second. But this is not the point. We wanted to build a architecture that supported growth with the number of users, number of systems we integrate with. It's also fault tolerant, right? Where pieces of our application fail with different integration systems, and we can still function relatively well. And then it also allows us for resiliency, where we can get back to good state once we recover from this. So we have a lot of headroom. Before we get into the components of what we built, I want to talk about the event. This is the soul of the event-driven architecture. And so some key things about the event is it's immutable, right? Once it's created by a producer, it can never change. And then when an event is produced, it is an indicator of a state change. So something happened from the producer side. And so it's historical, right? And then the event has some information in it, and this is a schema. This is the contract between your producer and consumer. And on the right-hand side, this is just an example of an approval event that we have. So it has some metadata about who created it, where it came from, the status of the approval, things like that. So it's used for routing and other things like that. Okay. So there's a lot to cover, but I just want to focus on how do we integrate with Salesforce instances. Okay. So I'm going to start with the classical integration pattern. So here I have a Heroku private space, and I have a Heroku app called Approvals in it. And it may have a Postgres database for state storage. Heroku makes it really nice to be able to provision these data services like Kafka or Redis. And so we decided to use Postgres. And it's connected through Slack using a WebSocket and using the Slack API to send messages, to respond to events, things like that. Okay? And so now we pull in Salesforce instances. We like event-driven architecture all throughout the stack. And Salesforce provides some technology out of the box for event-driven architecture. So they use platform events or CDC, change data capture events. And they're nice because when things are created in the org, things are modified or processes are started, these events can get produced by Salesforce. Okay? And then there's a couple of problems I'll mention, but you also need to, before you can consume events, you'll need to know how to authenticate, right? There's many ways. OAuth, you can use client credentials, you can use JWT in this example, and then you need to exchange, you need to authenticate with Salesforce to get an access token, right? So there are a couple of problems that I'm going to point out is that for the approvals application, your application needs to know how to consume these events from Salesforce. So you can use a library for like a PubSub library, a gRPC library, and then you also need to, if you ever worked with platform events, you need to keep track of the cursor, right, to know what message you're at in the queue. And so if your application restarts, you can pick up where you left off. So that's one piece. The approvals application needs to also know how to authenticate with Salesforce. So you probably need like an OAuth library of some sort to know how to authenticate with Salesforce. And then one thing that probably doesn't stand out is how do you know the Salesforce CDC platform event is talking the same language as the approvals? There's no schema verification or validation between the two. Okay, so now this is where a new add-on is being developed by Salesforce in Slack and Heroku called Heroku Eventing. It's another add-on similar to Postgres or Redis or Kafka, and it handles the things that I mentioned previous to the slide, where it knows how to authenticate with Salesforce and and refresh the session. It knows how to consume platform events or CDC events, and it handles all that for you. And now your approvals application will just need to know how, it could just be a REST API. And Heroku Eventing will just post to your approvals application, and that's it. For the schema part, Heroku Eventing doesn't handle that, but for us, we came up with a unlock package that we share with these orgs. So we built the platform for all of our applications, but we don't own any of the processes or the orgs instances at Salesforce. And so we created an unlock package with some interfaces, some models that they can use to generate the event itself that represents our schema. One thing I would like to mention is from the previous slide here is that this is just one example of one instance of Salesforce. Scale that out to 10 instances of Salesforce. Now you're managing for the JWT auth 10 different unique certificates and private keys, and then 10 different cursors, right? So that's one big problem. Okay, now let's talk about third-party systems like your expense system that isn't Salesforce or your HR system. And so for us, we needed a way for those systems to send us events as well. And so we stuck our API gateway in front of our whole application stack. It does very similar things as our unlock package. It does the validation of the event itself. So these third-party systems can send their message with our schema through our API gateway where the validation happens. And then, again, we like event-driven architecture, so we have a Kafka broker right in the middle where messages come in through the API gateway, we put it on a Kafka topic. And then for Heroku eventing, we just point it to Kafka, and then now our approvals application is just listening to one topic. Okay? All right, so taking a step back, this is just a snippet of our architecture, but you can see that we're integrated in 6 different Salesforce instances, and then some handful of third-party systems like Workday or Concur, for example. Okay? And they're all going through each, Heroku eventing or API gateway, but all land on our Kafka broker and goes through each of our applications. Okay? All right, let's talk about demo.
All
So
right.
before we start, I want to lay the foundation. Okay, so this demo, I'm going to have a scratch org. I'm going to call it IT, but that doesn't really matter. It has a platform event in it. And then I have provision a Heroku eventing, the add-on itself, and it's empty, not configured. And then on the right-hand side, I have an application. And you'll see that it's a worker because there's 2 ways you can integrate with Heroku eventing. One through as a web API, a REST API, or through a worker, which I'll demo first. All right. All right. So. Okay, so I'm going to show you, I'm going to make sure it's refreshed here. I have a scratch org, and I defined a platform event called TDX25 event. And all I have is a custom field called message on it, and it's just a text field, 255 characters. That's all we really care about for now for this demo. For the application, this is just an Express node server. And I'll show you what I have so far. We're going to start with worker, and we'll get to web shortly. But all it is when you provision the Heroku event add-on, it sets a Heroku event subscribe URL that you can consume from. Okay. I also have defined a Slack integration where I have the Slack bot. And I'll show you that in a second. But that's just how we interact with the Slack API, just to send messages to respond to events. And I have this set interval function. All it's doing is pulling that subscribe URL every 5 seconds, and it's going to receive the event and post a message to a channel. That's how I have it so far. All right. And on the Heroku side, here's my test app, and I have Heroku events. Both web and worker are working or on, just one dyno per for now. And I'll show you what that looks like shortly. And then on the Slack side, I just have this channel that's empty that I joined that you'll see a message once I show you that. Okay. All right, so first, if you remember, there's going to be 2 components to configure Heroku events. First, you need to set authorization with your Salesforce instance, and then you're going to create a subscription to the platform event. So let's authorize first. So let's go with. So here we go. Okay, so this is the first command to authorize. Again, it's going to be published in the Heroku documentation. But all it's doing is authorizing with a Salesforce instance. You're going to give it a name. I gave it TDX25 demo org1, for example, and then I provide a login URL. So if it's production, it could be login.salesforce.com. But since it's a scratch org, I just gave it the right domain. So I'm going to authorize. So it's going to open my browser. It's going to ask me to log in. Normally, you would use a service user, but I'm in a scratch org, so I only have one environment. Oh, let me log in real quick. Okay, so I have my username and password saved. I'm going to log in and say success. So I can close this. So my terminal, I'm authorized. All right, the second command is setting up the subscription, okay? So I have it baked here. So Heroku Events subscriptions, Salesforce create, you give it a name. So I gave it TDX demo org subscription, and then you specify the topic. So if you remember this right here references the API name of your platform event. Okay? And then you also pass it the app you're applying it to. So this is the Heroku app name. And then you pass it the authorization name that you set in the previous step, right? I named it TDX25 demo org1. Okay, so now it's all set up. On the org side, I'm going to just use some anonymous Apex. I'll show you what that looks like. Sorry about that. Show you this. So, okay. So all I have here is I generated a platform event, and I set the message, that custom field that I showed you previously. All it is a text field, and I'm just going to send hello TDX25 in it. And then I'm going to send it to the event bus and publish it. Okay. Before I execute, I just want to open the logs and show you what it's doing in the background. So if you look, remember, 5 seconds interval. So it didn't detect any messages, so it's just going to keep running for five seconds. All right. So on the Heroku event side, let's see. Okay. All right, I'm going to execute. Success here. And then if you look in the logs, it just spat out. I have a console log that said the whole event. And you can see that there's a message, hello TDX25. And then in my channel, I have it posted. Okay. All right. Okay, so that's one pattern. I also want to show you the web integration pattern. So this is a little different. It needs a third component. And so you need to create an event stream. And you can think of this as Heroku eventing posting to a webhook, a REST endpoint. And so that my REST endpoint is the web dyno. And so if I go back to show you what web looks like, right here. So in the server web, I just have a receive endpoint where it's doing the exact same thing the worker was doing, except it's not running every 5 seconds. All it is just waiting for event to hit the endpoint. And it's just posting a message. Same thing as before. Okay. I'm going to turn off the worker while I do this, because if I left it both on, you will see 2 messages. So I'm just going to turn off the worker for now. And then I'm going to switch to the web log. Okay. Okay, so back to our terminal. We're going to create that third component, which is that event stream. Here, let me clear so it's a little bit more clear. Okay. All right, so we're creating the event stream, the webhook. Similar command, events publication webhook create. You're going to give it a name. So I just gave it, org event hook. And then I told it what app I'm going to apply it to. And here, the URL parameter, I'm going to pass it the endpoint, the webhook endpoint. So this is the domain of my application /receive. I showed you in the code, the source code. Okay? And then I'm going to tell it what subscription that this webhook should listen to. And you can imagine this webhook can listen to multiple subscriptions. But right now I only have one. Okay? I'm going to set that up. Okay. All right. So we can do the exact same thing. One thing I've seen that it takes a little bit for the webhook to initialize, so I might need to send the message twice, but you will see the example. So I have my logs, and then I can publish an event. So success here, and it didn't look like it initialized. So I'm going to try again. There we go. Okay. So this is a web again, and it received the event. And then in my application, I prefixed it with web, but it says the same message, hello TDX25. All right.